How's it going, Charles? So, still continuing with exercise 9.3. I'm going to be doing numbers 10 and 11 for you guys. Okay, so if we have a look here, it says the graph represents a cubic function y is equal to f of x. A, B, and C are the x-intercepts. So we have A, B, and C are the x-intercepts. I just want to highlight that for you. So we have an x-intercept over there, and over there. All right. Then it goes on to say that D and E are the x coordinates for your turning points. Okay, so that is the x value for our turning point. That is the x value for our turning point. And then H is the x value for the point of inflection. So that's our point of inflection over there. Write down in terms of the given constants the values of x for which f dash x is greater than 0. So remember, if we're talking about f dash x, f dash x is the same as saying the gradient, okay? And here they're saying f dash x greater than 0. So if we have a gradient that is greater than 0, we are looking for a line that is going in that direction because it has a positive gradient. So that's where I'm looking for my graph going in that direction like that. So as you can see, from there to there, our gradient is negative because it's going in that direction. Now just remember, at this point here, our gradient is 0. Okay? Then from this point onwards, our graph is going in that direction, and that is the direction that we want. We want it to be a positive direction, a positive gradient. Over here, our gradient is 0 because it's a turning point, and then thereafter, our gradient is negative. So, where is our graph positive? Well, it's going to be positive between this x value and that x value there. That's where our graph is increasing. So, x will be an element from D up to E. And both of these are excluded. They're both round brackets because at those points our gradient is 0. And that's not what we're interested in. It's strictly greater than 0. Okay, so question B. They're asking where is f dash x equal to 0? In other words, where is our gradient 0? So our gradient is 0 at our turning points. So here we just get two x values, so we'll get D and E. So x will be equal to D, and the other one is x is equal to E. Question C, f double dashed of x is equal to 0. Okay, so as you saw here, f dashed x equals to 0 finds your turning points. F double dashed equals to 0 finds your point of inflection. So that's where we're looking for, is our point of inflection, and it was here where h is. So x is equal to h is our point of inflection. All right, so now question D, where is the graph concave up? So what I want to do here is I just want to summarize concave up and concave down. So concave up is in that direction. So this is concave up. This is concave down. Concave up happens when f double dashed of x is greater than 0. And then concave down happens when f double dashed x is less than 0. Okay? But what we have to do with our graph is we just have to look for a shape like that or like that. But in this case, they're asking for concave up. So I just want to make a note here, concave up. And concave up is going to be this part here. Okay, so concavity always starts or ends at your point of inflection. So if I have a graph like this, and there's our point of inflection, okay, the concave down would be this bit here. From there to our point of inflection, and then it stops there. Then our concave up bit would be from our point of inflection and onwards, okay? So this bit here would be your concave down, and this bit here would be your concave up. Okay, so we have to stop at the point of inflection or start at the point of inflection. So we're looking for concave up, so there it is there, and then we must stop at our point of inflection, which is right over there. So it will be concave up will be, and I can write this in two different ways, from minus infinity up to h, which is our x value. So minus infinity up to h, both of these are excluded and x is an element of that. Or what we could say is it's anything less than h. So x is less than h. These mean the same thing. So you can write it either way, guys. All right, so now we're looking at question E. It's asking two things now. It's saying, where is our derivative 0? In other words, where is our gradient 0? Well, it's 0 at this point and at that point. Only those 2 points there. Then it's also saying, where is the second derivative less than 0? Okay, now the second derivative less than 0, you remember, second derivative less than 0 is where it's concave down. Okay, so where does it both derivative 0 and concave down? Well, here our gradient is 0, but this is definitely concave up. All right, so yes, it fits this one, this criteria, but it does not fit this one here. Over here, we have a derivative of 0, which fits this one, and that is concave down, which is that one. So that does fit our criteria. So for question E, x is equal to E. Okay, then we've got question F. Where is f of x less than 0 and f dashed x greater than 0? So when they're talking about the f of x, so I've spoken about here, f dashed x is your turning point, f double dashed is your point of inflection. I just want to talk about what f of x is now. F of x is your y values. Okay, so it's the y values for the original graph. So what we're looking for here, what they're asking here, is where is our y values negative and where is the gradient positive? So let's have a look where our y values are negative. Our y values are negative for this original graph from this point all the way up to that B point. From there, it's positive, then positive over there, and then positive over there. Then our y values become negative again. So we're looking for where our gradient is positive. So our gradient is positive between here and here. Okay, so I can ignore this bit now because our gradient is negative there. And our y values are negative from here to there, and our gradient is positive from there to there. So our x values would be from D up to B. So x is an element from D up to B, both exclusive, like that. All right. Another way of writing this, guys, is that you can just say x is less than B, but greater than D. Okay, they mean the same thing. Now, let's have a look at question G. Question G is asking where our y value is positive and our gradient positive, f dashed x positive. So our y values are positive over here and over here. Over there and there, they are negative. We're also looking for where our gradient is positive. So our gradient is only positive between here and there. Okay. Now it can't be this bit here because they told us that the f of x or our y values must be positive. So it's only from here to here that fits both of these criteria. Both our y values are positive and our gradient is positive between there and there. So that is going to be between B and E. So this is question G. So x is an element from B up to E. Another way of writing that is x is less than e, but greater than b. All right. Okay, grade 11s, I'll make a separate video for question 11.